Welcome to this session and to this talk. Hans-Christoph Steiner is going to give you a talk on wind, off-grid services for everyday people. And it will be a network-related talk, and I'm very happy to welcome him on stage. Give him a warm hand of applause.
Thank you. I will be talking about our Project Wind, which you just said, about really our work over the last 7-ish years about integrating offline connectivity with kind of nearby networking into the internet and making that something that you can use transparently. I'll give a little overview of some kind of randomly chosen, or not so randomly chosen, historical precedents that I think inform this whole discussion, talk about some of the work that, well, a lot of the work that we've done, and other examples that have been presented at Congress and other places, and also hopefully inspire everyone here who works on software of any kind, maybe even hardware, to also think about nearby and offline networks and how to integrate it into what you're making. This work is kind of under the umbrella of the Guardian project. We are a free software project focused on privacy in mobile. We make, that means when we do software development, we started with the idea that we want to make apps where privacy comes first. We don't want to compromise at all on privacy as in the whole process. So that means, we haven't become rich and famous because we've opted for grants rather than VC money and things like this. One central idea for us is that the design, the usability of software is not in conflict with privacy, but really actually an essential part of delivering software that is actually secure and private. If people don't understand what they're doing, then they're much more likely to make a mistake. And if you design things in a way that the user has to choose between the dangerous button and the safe button right next to each other, then that can cause a lot of problems. So central to our design process is really thinking about user experience. So this is, instead of saying, the user didn't understand it, we need to write a manual better, we need to teach them better, we say, no, we need to make it so that the software matches the people's expectations. We need to present it in a way that the expectations are clear, and this means a lot of talking to people, a lot of iterations, and a lot of trial and error. Guardian Project specifically focuses, the users we focus on are from activists and citizen journalists, and human rights defenders, people, anything from like election monitors, et cetera, et cetera. We are often called upon to help inform software that's used in businesses, or business people who travel use our software. And frontline reporters, but really, so the core mission was we really want to make privacy and these kind of things something for everybody. And we've kind of found this niche where we can work in partnership with all sorts of organizations who will give us money to focus on these people like human rights activists. And that we develop free software, and we try to push it out there in ways that it can be reused, both in terms of free software libraries, so that you can incorporate that into your apps, but also in terms of design research, design patterns, and things like this. So these are just a bunch, some of the, not all, but some of the partnerships. These are, a lot of these organizations represent, say, the target user. And so whenever we're designing software, we're always working in conjunction directly with people who have strong privacy concerns that we're trying to address, and other, accessibility. And we also always try to find, if there's already a free software project out there doing an essential part of what we're doing, we would much rather try to support another free software community than invent it ourselves. So this means we have to do a lot more talking as well. But so that's part of coming to an event like this, is to say, okay, where are the parts that we all can work together and make something better? Yeah. So I should also mention that I kind of wear many hats. I pay my bills usually through Officially Guardian project, but the way we work is that we often do a lot of the work just because we think it's important. I'm also a Debian developer. I'm also a core team of F-Droid and other things like this, things that don't necessarily pay the bills, but because we have some funding here, it means we can also have time to focus on things that integrate into the whole thing and are also really important. So, networks. So everyone's familiar with the internet, and the internet is now on our phones and in our pockets all the time. And I think more and more people are forgetting that there used to be lots of all sorts of kinds of networks out there, and that I think so I wanted to highlight a couple that were influential to me, and also just to point out that there's things we can learn from them, because some of these ideas people think, well, that's crazy to build a system like this. It's too hard. Well, and you can look back and say, well, actually, this was working pretty well not so long ago. Who here has heard of FidoNet? Some, okay. FidoNet is probably my first exposure to anything like a network. What it is, quite simply, was back in the days when a connection to a network was a modem and dialing into something. There was a thing called a BBS. It was basically a one-stop. It was one computer that lots of people could call into, and you could exchange. You could chat, you could find files, things like this. So a bunch of people figured out, well, if we want to exchange data to across the country, that's a very expensive phone call. But I can make a local call for free or cheaper, and then that BBS can make another local call, and that BBS can make another local call, and then we can have a global network that's actually affordable. And that's FidoNet spanned a large part of the world. It went from U.S. to Bulgaria, I think a little bit into South America, and just organized by people who wanted to be able to send little emails and things like this. Then, for me, one that's near and dear in my heart, anyone ever used beaming apps and Palm Pilots? So this is something I think is quite important. This is it has the idea of offline nearby networks built in from the beginning. Anything as far as I remember, if you had an app, you could beam an app to someone else. You'd be like, hey, here's this app. You want this app? And you point the devices and made a little noise. You could also beam contacts and things like this. And it actually worked pretty well. And it was just based on the same little infrared sensors as a TV remote control. And I think that it worked because of the technology was there. But more importantly, I think, is that they got it smooth enough, and this kind of interaction we were already talking about, oh, give me your card, or pull out your thing and pull out your Palm Pilot and point them at each other, was already kind of plugging into an existing human behavior. So it wasn't telling people to do some totally new weird thing. One thing that's getting a lot of media attention right now is El Paquete Semanal, the weekly package in Cuba, which is a really pretty amazing network of couriers moving hard drives around Cuba. What it is someone either goes to a country that has high-speed internet, or they have, through some source, they get it on Cuba. So for people who don't know, most of Cuba doesn't really have internet access, and the internet access that is available is extremely expensive. So people have figured out this thing. Well, they just buy a hard drive, and they fill it up with ebooks, movies, all sorts of things, apps, games, and then someone brings it into Cuba. They have a whole network this is a network that's of people who talk to each other and meet up, and they physically exchange these hard drives. So someone says, oh, I got the new weekly packet. You have your weekly packet store. You know someone who gets it from someone. You go make your copy. Then people say, okay, I want to get apps. They go to the weekly packet store. They pay a little money. You get some time on the hard drive. Copy what you need. And this covers Cuba quite well. And there's no wireless networking. There's no wired networking. It is people moving hard drives around and talking to each other and agreeing. And I mean, so this has often been kind of derided as sneaker net, which is something near and dear to us. I mean, and something as a last resort. But it turns out that SneakerNet is still the fastest way to transmit data. So Amazon has a service where if you have a lot of data and you want to move to Amazon, they drive a truck. They drive a truck to your data center and they plug it in and you load it up. And this is an exabyte of data. And I mean, I don't know all the exact details, but something like an internet, for one example case, it would have taken 26 years to do it over the internet, and it took them 6 months with this thing. So it's just really a truck full of wired hard drives. And then I feel like mesh is fading a little bit. So this is something there was quite a bit of activity maybe 10 years ago of people building DIY networks that can figure out how to route data through them by kind of on their own. And that's the core idea of a mesh network. And so this specific map is the Wi-Fi network in Catalonia. You can see like that is Barcelona, where the mouse pointer thing is. But so it covers quite a large area. I think it's 10,000 nodes. And to this, it's provided actually relatively high-speed networks in a place where the local telecom companies haven't really been interested for whatever reason in doing it. There's actually a kind of it's kind of a hard thing. So this is built by and set up by a whole lot of volunteers, and that takes a lot of people's time and technical ability. And what often happens in cases like this is that then they've done the hard work of actually proving that people want the internet, and maybe will even give some money to it. To support it, and then the companies often come in and be like, "Oh, look, that's a market waiting for us," and then poof, and these things go away. There's another I just learned about it yesterday. I mean, the outcome, but there's a telecom in eastern Nicaragua called Seycell. Very similar idea, kind of DIY community-based effort, because the local telecoms were not interested in eastern Nicaragua at all. They set it up, got it working, and then the telecom saw, oh wait, people will actually pay for telecom service there. And then they, of course, then set up lots of towers and put Seycell out of business. And of course, the internet itself started as an offline network. That was, 1970. That was the internet. That was all of it. And this was, built node by node, starting, when they first turned it on, it was 2 or 3 computers talking to each other, and bit by bit, it was built out into what we have now. And on top of that, so that was a U.S. Defense Department really funded effort. But then lots of things started kind of butted on top of that. So Usenet, which is still alive and kicking today, and is a fascinating idea of how to move. So it's basically like forums, and it's all organized by topics. And back when it was created, the internet was not really available, and people wanted to say, well, we want to use these digital media. We don't have access to the internet. How can we do this? So similar to something like FidoNet, this is computers calling each other, syncing up data, and what you get basically is this. So someone, like a university, will have a complete copy of Usenet, and then you can connect to them, whichever is the closest to you, and say, well, I'm only interested in this much of it, and sync with them. And then syncing includes putting your responses back in. That university takes your response and then forwards it to every other connection, and it spans the world in these asynchronous kind of bit-by-bit connections going in every direction. A more recent one, which to me is such a clever hack, both politically and technically. It's called Touché. It's basically about getting around internet blocking in Iran. Has anyone heard of Touché? No, I guess not. So it turns out that Iran often blocks aspects of the internet. Satellite TV is very popular in Iran, but the satellites are all operated by, I believe, UAE, the United Arab Emirates, and those countries don't get along. So that is the people who put Touché together recognize, oh, this is an opportunity for us, because ultimately a satellite video is just bits. And it turns out it's a standard format, it's MPEG format, bits. So there's no one checking that your bits actually are a nice, pretty, playable video. So Touché is a system where they have a cable channel on a satellite run by the UA that's targeted it's available in Iran on the main satellites that Iranians use to get television. And if you subscribe to it, and you basically, a lot of these little satellite boxes you can download to a USB thumb drive. So you can just download, stream data to it, and then they have a little app that extracts, just like unzipping a file, but it's taking data out of MP4. So this, to me, the whole thing is just, I don't know, such a crazy hack that works that I found it very inspirational. So then why do we now really want to think about incorporating offline and nearby networks? Like, there's all these things before, that was the only way, or there was a direct need. And now it feels like, well, it's so easy for so much of the world to just get stuff on the internet. Companies like Google have really pushed this idea that, look, they can provide always connected services, and when you're always connected, then they can run these huge servers and have these insane search indexes and all this stuff that you can't do or no one's been able to do in a decentralized way. So they're so invested in this model of always connected internet everywhere. They're flying balloons. Facebook as well. They have their idea of putting drones up to beam internet, always connected internet around the world. And to me, I've always been very fascinated in the history of computers and the internet, and it reminds me of one I think often overlooked but very important story in the roots of the internet and computing, and that is a lot of this stuff like the internet was being built around when the Vietnam War was being fought. And while we usually think of like a lot, oh, the internet was a bunch of hippies making internet access or information available for free, that was happening. At the same time, the people who actually were funding this, the people in charge of the U.S. Defense Department funding, had a very different idea. Their idea was about, well, if we have a nuclear war-proof network that spans everything, then we can have the most efficient centralized command control possible. We can build a network where we have people taking care of everything, and then when it'll be so efficient that the president can actually decide which person to shoot. They'll just be able to flip on a monitor, and the airplane will be flying in the air, and the president gets to pull the trigger. This is not a made-up story. This is really part of what they were thinking about. One of the things that they did, so in that time, so around 1970, the largest computer in the world was in Thailand, because they had built a network all up through Vietnam and Laos and Cambodia, where the Ho Chi Minh Trail was. This is where the Vietnamese brought weapons from the north down to the south to fight. So they had this idea, well, we'll just build a network over the whole thing. We'll wire up sensors and video cameras and audio sensors, and then we'll know where everything that's happening on this trail. And then when we want to blow up some truck or something, there you go. The general can sit there and be like, that one. And we'll have perfect knowledge. So huge amounts of money, largest computer in the world. They built the system, and it was reporting all these statistics about all the things that they have killed and blown up. Here they have a nice map of all the places that were targeted via this system. And then after a while, someone tallied all the numbers that they had of all the trucks and airplanes and everything and people they had killed with this, and they realized that it was much larger than any of the estimates from the departments who just were trying to estimate the size of the military. And then after the war, you can now see this in museums in Vietnam. The Vietnamese have figured out, oh, here's a microphone, and when it hears a truck, someone shoots at it. So they just played recordings of trucks. So this was really, they had centralized command and control. They built this amazing infrastructure, internet, up on the whole, in this rural thing in a war, and they were victims of their own information bubble. So, more directly, why do we need offline and nearby networks? Well, what we have is centralized, and getting, seems to me, even more so. In some places, in many places of the world, it's very fragile. In pretty much any place in the world, it can be fragile at surprising times. I worked in Lower Manhattan during September 11th. There was no internet, no phones, no cellular phones for weeks. There was no power. There were power lines this big in the street. So this can happen, in the middle of New York City. In a lot of the world, it's expensive. It's getting, easier and easier to censor it. Everyone knows it's being surveilled in so many ways. And of course, it's lots of people are trying to push it to not be neutral, like prefer certain services over others. So it's also not evenly distributed. So this is a map of the world where, based on percentage of people using the internet, very unevenly distributed. And so part of why that is, well, it turns out that it's quite expensive in certain parts of the world, and often in those parts of the world where people don't make a lot of money. So really, I mean, affordability is a huge block to getting on the internet in a lot of places. I mean, this is something that Facebook has figured out with their internet.org program. They basically figured out that, you know, if it's worth it to them to pay for the internet bills for people around the world to access Facebook. But then, of course, they don't pay for the internet bills as a whole, just accessing Facebook. There's even, I mean, another example of a project that we worked on. So in the US, there are large parts of the US where people are that do not have coverage. For example, farms, a lot of large farming areas. And so we worked with a group representing farm workers in Georgia. We were helping them track the work that they did so they could get paid fairly. And for the most part, they did not have access to mobile connections or the internet. This is in Georgia, not hardly the most remote parts of the US. There's also lots of places in the world, so here's an example of Syria, where there's actually the internet, the connection to the world outside of Syria is pretty tenuous. Tartus basically has 3 connections, and then there's one in Aleppo, and that's it. And in some countries, they've designed them deliberately like this. So Libya, after the fall of Gaddafi, they were able to kind of go in and look at how the telecom was built. It was built to have one central building that could control every aspect of telephones and internet. And another nice example were these in Hong Kong, these protests that broke out, and they occupied this causeway. So it's kind of a very unexpected thing to have tens of thousands of people in a highway, and there was they were trying. It was political demonstrations. They were trying to get themselves heard, and they had put a lot of effort into trying to communicate and also keep abreast with what the police were doing. And there was quite a bit of attention about. I forgot the name. There's a service of a chat app that had a remote what? No, this one was specifically about having a local connections. FireChat, yes, thank you. FireChat, and it got a lot of publicity here, but and that one was quite interesting because it worked as a regular chat app. But if you couldn't connect on the internet, you could also try via Bluetooth to send messages through the network. So it's a nice model of saying, okay, well, internet, if you have it, and ad hoc mesh if you don't. So now, I mean, these are a lot of nice ideas and hard technical issues. How can we do this? That's part of the question that we've been working with. Our most recent work has been related to a Mozilla competition around offline networks. And we we chose to focus on Latin America and to kind of broaden our horizons. And we started out, we had done some work over the time. We started out with some surveys to get some ideas of what were the issues, like what were the concerns about people. So these are the respondents from these countries that we talked to. Then we're just trying to get some general ideas about, when you're using a phone, what are the problems that you have, and so the cost of data was number 2, and batteries number 1. So we had come at it with a perspective very much thinking that what we had heard, we had just learned a lot about how expensive it is to use phones in a lot of parts of the world, and that was our focus. So then we were surprised to see, actually, yes, that's a concern, but battery time is the number one. So from this also we say, how much data do people use? So 2 gigabytes or less is about half the people that responded, so not so much. And then how much they pay. So most of the people were paying more than $20 a month, which in the EU is not so much money. In a lot of places, that's a lot of money. That's a substantial portion of their income, so about 10% of a lot of people's income. And from this, we did a lot of interviews and things like this, and we find that having real stories is very informative to the process, but there's a lot of privacy concerns to that. Actually saying, can we interview and spread your story about your concerns around the world? So what we did actually was, based on our surveys and interviews, we put together fictional people, and these are 3 of them, and try to keep them close to what we were hearing. And so these are, I think there's 8 or 10 or so, all available on the OK Thanks website. It's linked on the talk page. And it just kind of tells a little bit of their story, their phone, their income, and things like this, what apps they use, and what they do with the phone. And these were for us, very helpful in thinking about how to prioritize things. Battery. We put more effort into battery conserving. Then, based on that, we went back. The longest running piece of this work is in F-Droid, where we started in about 2012 with this, what we then called app swapping. And from there, we've tried to think about, so F-Droid is an app store. It's all about getting a blob of data from somewhere to your device so you can use it, whether it's an app, a video, an ebook, or whatever. So in F-Droid, we really have this opportunity to think about, what are all the useful ways that we can move blobs of data from here to there? And how can we get them all into one user experience where you don't really have to be aware, you don't have to say, I have to set up, the internet's not working, I have to set up the Bluetooth connection in a special way so that I will be able to use it. So we wanted, or mirroring, or blah, blah, blah. So and this is really taking shape more and more. On the left there you have some of the many ways that that data gets transmitted in the F-Droid ecosystem. So of course you have, up top is fdroid.org. It is there by default. You open up the phone with the internet device, search for an app, install it. If the internet's working fine, it will just download it from there. In each in the fdroid.org can declare, I'm also available here in this mirror. If you cannot reach fdroid.org, you can try the repo on this server. So that's available in there, but the client knows to say, okay, I can't connect to this one. It's been, so what's the next in the list? And we'll try that, and it'll keep on trying. And then users, if you have your own server, you want to set up your own mirror that's closer to you, you can set up your own mirror and add it anyone and share it to anyone. And that same logic applies. The user doesn't have to know that the main one failed, or even there's no notification or anything. It just keeps going until it can't find anything. If it can't connect at all, then you're notified. So that still is a centralized server. That is fdroid.org is a central community of people. Everything that F-Droid makes is free software, and we try to make it easy for the people to use it. So, for example, there is a Guardian project app repository or repo. Anyway, you can just kind of subscribe to it. You can send the link via email, click it, and after it says, do you want to add this? And then that also can have its own mirrors. And you can have as many of these as you want, each with their own mirrors, each with their own setups. And then we have the nearby functionality. So every phone has radios that can talk to each other. There's Wi-Fi radios, there's Bluetooth radios, and these are set up to exchange data. So in F-Droid, it has the Nearby tab to help you walk you through the process of making a connection, so you can exchange apps. Any app or video or things like this that is installed on your phone, you can make it available and connect to someone else's device. They see it in the regular App Store experience, click install. And also, then there's the problem of, you need to do this procedure, you need F-Droid talking to F-Droid. So if you want to send, say, I have an app I want to send you. I don't have F-Droid. Okay, well, I can just send you F-Droid straight. So that's a relatively straightforward thing. That's here on the left, of just saying, okay, well, I'll send you F-Droid first, and then the rest will be much easier to sync up. And then, of course, it needs to also play nicely with other app stores. So the world of Android, people are used to only having Google Play, but large parts of the world, many app stores is normal. China, for example, India, other places. And for this to be a whole ecosystem, they all have to play nice. So if you're getting apps from Play and then you also install F-Droid, then F-Droid will do what it can to work nicely. You can, of course, then, if you install an app from Google Play, you can, of course, share it on using any of these things. And then we recently saw a nice, kind of a surprising example that someone came to our chat room and just said, oh, by the way, I've set up a store in Cuba. And so because we put the effort into the whole tools to make sure that if it can talk on a network, it'll work regardless of whether it's the internet or not. This man in Cuba decided he was going to open a mobile phone store, and he thought a good way to promote his mobile phone store would be to have a local Wi-Fi access point that you could connect and get free apps. And so that he was on the edge of town, and he said, well, if you come here, you can connect for free to my network, you'll get free apps, and then, if you need a cable or El Paquete, I think he does that, then my store is right here. And so this is a kind of this is an interesting model to me, because it's, for the most part, it's offline. It is one Wi-Fi access point with a hard drive plugged into it, more or less, and it works. And then every so often, he syncs with the internet. So it's a kind of like once-a-week internet connection. And along those lines, there's these little things, like all sorts of little boxes that have Wi-Fi and storage in them now. And this one's called Library Box of Software for it. It makes that idea of this kind of occasionally syncing to the internet and having a local store very, very simple and very cheap. So I also want to point out, we're not the only people doing this work, and really what we hope to see is a lot more people focusing on this kind of thing and doing it in a way where we can interoperate. So Briar's messaging app, there's a talk from last year here at Congress from Torsten Grote, which it's a very similar idea. It uses the internet when it's available, but it also can do local connections for sending messages. We worked a lot with Tibetan activists in Dharamsala in northern India, where a lot of Tibetans are based. They are quite remote, didn't have networks. They've set up their own whole systems of both a network and computer systems that cover their area. Then, I mean, what we're seeing now, even the Silicon Valley doesn't have perfect connectivity, so you can get offline maps on things like on Google Maps. And we're seeing, Apple and Google now are also pushing this nearby idea. It's I guess, hitting the mainstream. And specifically, so, they have huge engineering resources, which is a wonderful thing to see on that, but they always come, in the case of Apple, they often, make it work really nicely, but then they stick in arbitrary restrictions, like, iTunes is not allowed to do nearby because they don't want you sharing music, and Google, of course, adds in extra tracking, because that's their business model. And from Apple, there's a very important lesson to always, when you're designing systems, think about spam and abuse. This is apparently become a thing in New York where people are doing AirDrop. Apple AirDrop is their nearby service. Dick pics to anyone who's on the subway who happens to have left their AirDrop in. I guess there's a kind of listen all mode. So you open your phone and it shows you the picture right there, right? Less than ideal. And there's also two apps called Share It and Zappia, which have many millions of users, which do this nearby sharing quite well, but that's what they look like. To me, that doesn't look like they're really focused on the nearby so much. I mean, when they started out, it was very simple and it worked nicely, and then it's the same, they're startups. It's the same business model. Now they're trying to track and monetize you with like endless swipey things. So, we need to do it another way. If we really want to have something like that's neutral and nearby and working offline, it's not gonna come from Apple and Google, and it's not gonna come from the VC funded startup. And for to highlight really the way we're thinking about it, like what we want to put up first and foremost is that ultimately we want people connecting to people, and thinking about how people act rather than encouraging them to act in a way that works with your business model, and also putting this into the design of how the protocols work. So this is some early thinking from Paul Baran, who's a researcher involved in the design of the internet. So it's interesting, 1962, he's thinking about centralized networks, decentralized networks, distributed networks. But these all assumed that those points don't move. But people move. And now that we all have phones, we have to consider that movement is always going to be part of this. So that means at some points you will have a great connection to the internet, so you can use it. And then maybe it's that centralized hub and spoke. Other parts, it might be some more decentralized. And other points, it may be just connectivity to one library box that has specific services that you may or may not need. There's a whole range of things that need to be considered to make this whole kind of fluid experience actually work. To break it down, I mean, we have these kind of concepts as our kind of core. First is what we call chime. That's the idea. It has to be discoverable. If someone sticks a little Wi-Fi box there, if your device doesn't know how to find it, then it becomes, it's quite a bit of work to actually use that thing. And you need something to store data in order to have an effective model where, say, you have the once-a-week internet. You also need a way for people to send their stuff out, to gather and share it out. And so one thing I think is that the most, from this most recent work, that is the most generic and reshareable is to actually say, okay, what is the format of data for announcing yourself and a service that you're offering? This is our first draft of such a thing, the wind chime announce protocol. And so this needs to announce, I am available on this Wi-Fi node, so the SSID, BSSID. I am available at this address. I am available at, whether it's Bluetooth or not. And this is the kind of service I am providing. And it has to be in a standardized way so that it can happen automatically. You don't want to present a whole list of text with many things to the user. That's not going to ever be useful. Then we also have this available in a library for Android called Ayanda, which just tries to make these core pieces really easy to do in an app. So that's the discovery piece, the sending files and the receiving files part. So then the question is, how can you get started doing this in software that you're working on? And some of it is just a matter of trying, as we've learned, where most of the time you think, well, if I have a network connection, even if it's just a local network with small nodes, it should just work, right? If I'm on a mesh network, it should just work because it's all the internet. Well, it turns out it's pretty normal to check for specific things that only exist on the internet. And then that ends up being the only thing preventing your software from working in a nearby or offline way. So that's the first thing, just to set up a network of, or get a library box, one node, see if you can talk to it with your app. Does it work without a domain name? So we're used to, ccc.de, but if you just have an IP address, just the sequence of numbers, will your app work? Because that actually, the domain name makes it a lot harder to set up individual lightweight nodes. And then, in the flow of using your app, is there data that can be sent and cached in a way that's not, say, leaking private information, things like that. And just starting to think about that is the first step of saying, and with a lot of little tweaks, a lot of software can work then on nearby and offline networks without big fancy changes of syncing with Bluetooth and things like this. So to wrap it up, I just want to say that really what we wanted, we know that this is possible. So we want to build this network in a way that reflects our values instead of always turning us into a product. That means building a network that will do something useful if the big provider is not available, making it easy. That means building systems that you don't have to ask in advance to set them up. Just buy the 30 euro TP link, turn it on, and it should work. In some form, there's lots of things like official things like domain names which help, but it shouldn't be essential. And then thinking a lot about, well, how can we keep this affordable? I mean, affordable, accessible, and without any kind of arbitrary things like, well, you can sync anything you want, just not iTunes songs. So affordability, then, it might feel like, well, it's less important here, but when the system is made up of affordable little bits, that gives you a lot more flexibility in how you build it. So it really applies kind of everywhere. And in closing, just to leave a little something that inspires us is these are these starlings in in England that every night gather and just fly around in these swarms of these self-organizing swarms, which are many different individuals, some leading, some following. The leaders change. It's I highly recommend watching. The videos are amazing of these birds, and if we can make networks with that kind of fluidity of organization, then that would be quite an amazing thing. Thank you.
Thank you, Hans-Christoph, for your talk. And we have still some time for questions. If you have to leave, then do so quietly. And we have 2 microphones, one over there and one in the middle. And of course, the signal angel. Just line up and I will call you to ask your questions. Don't forget to be quiet while walking out. Maybe a little show of hands if somebody wants to ask a question but cannot reach it because there are people standing in front of the mic. Yeah, there. Okay. Just walk up to number 2 that's sitting right over there. And go ahead.
Yeah, so you talked about the Barcelona case where they have some kind of a mesh network already, as far as I understood. And you told us that probably the telco providers will come there and take like the piece of cake there and build their own business model there. But what are the limitations? So why is it possible? Because I think if the infrastructure is already there, it should be cheaper to maintain it than to pay extra for the telco providers.
Okay, so you're talking about the Nicaragua case?
No, for example, the Barcelona case.
Oh, the Barcelona case. Well, the problem is, if you have a company, if you have good competition and they can build the networks cheaper and maintain them and do them in a way that's with net neutrality and things like this, that's great. But I think part of the motivation in Catalonia is that they don't have much network competition, and in Nicaragua very much so. There's there's a Spanish company and a Mexican company, and that's it. They're huge, and so that these companies are not responsive to what people want to do and often put arbitrary restrictions and things like that. Does that answer your question? Or,
but I was kind of wondering why it's not competitive. Why like the independently built infrastructure is not competitive?
I think in the case like of Nicaragua, the telecoms they have lots of money. They really don't want anyone to have set a precedent of being effective competition. And so they were like, oh, they're actually getting subscribers, let's crush them. I mean, they're monopolies. They're huge, huge monopolies. That's part of it. So I think it doesn't matter the cost, really. They don't want people getting the idea that they can start competition.
Okay.
And yeah.
Okay, microphone number 1.
So you currently focus on mobile technology. Do you consider the desktop or the laptop out of scope because it's irrelevant, or just because you want to make it a feasible project?
So for the general idea as a whole, absolutely, it's fully in scope, and yeah, we want to see that. Me personally and Guardian Project as a kind of organization, our development work is on mobile, and that's why this have such a mobile bit, but we'd love to see desktop and things like this.
Okay.
Number 2, please.
Hi. Thank you for your talk. I have actually 2 questions. One is, as far as I understood right now, the Bluetooth is the way to go for these decentralized networks, at least what people are doing right now. And what is the biggest thing that we have that people have accomplished until now? Like, what is the biggest decentralized network, Bluetooth-based, maybe in this chat client or something? And the second question is, you mentioned a lot of technical problems that happen. And so how does the routing actually work with this Bluetooth stuff? Do you have like geo-based routing, or do everyone knows everyone, or yeah? Thank you.
Yeah. So yeah, let me see. Start with a simpler question. So it's not just Bluetooth. So it'd be Bluetooth. So you can do Wi-Fi just if you have an access point without the internet. That works. There's also things like Wi-Fi Direct, which seems to be can work nicely, but not always. So really, you have to kind of consider all of them if possible, and not one, because Bluetooth is often the easiest to connect, but really slow. Where Wi-Fi is harder to connect, but much faster. Then the largest, I mean, Usenet is the largest. It's like terabytes of data. The way I mentioned with the forums copying around. That is generally copied around on the internet. That's the largest one that I can think of. And the last question was, routing. So that's, I think for a lot of, so they really would, this wouldn't really be on the kind of transport layer where you're thinking about routing. The idea more is to say like, well, so if you want to do ad hoc routing, then you would build a mesh network, because mesh networks are all about ad hoc routing. FireChat does some, I believe they do some ad hoc routing in a very small scale in Bluetooth, and some of that I think is freely available, if I remember. And so really the idea is more that, so like in the case of F-Droid, I think is easiest, is that you make, there's a system where we have a concept of a repo, which is a collection of apps, and et cetera, files, and it has a kind of a globally unique ID. It's the signing key. So that means when the client encounters some files, it can easily identify it as, oh, it belongs, I know this is fdroid.org because it's the matching signing key. And it can just say wherever it found, as long as it can talk to these files, I mean, then it can exchange data. So there's no routing there. If it's on a mesh network and it gets an IP address on that mesh network and it gets to the same files, the index knows. So it's about, in the app you have to think about, okay, what are the things we need to discover? What are the bits we need to move around? And how can we do that in a way that's reusable? You know, it's very easy to just connect to the internet and say, oh yeah, use this domain name, assume it's always there. And I think for that, so F-Droid is one example, and I think Briar is probably a very good example where they're integrating internet and Bluetooth and local Wi-Fi to do messaging.
Okay, just to check, is there a question from the internet? No questions from the internet. So then number 2 was there before.
One of the things that I noticed is that you're talking about apps and F-Droid and distributing apps and then connecting to local nodes. What about IPFS, DAT, and some of the other distributed networks? I'm sure you looked into those, and you were talking in the beginning about like integrating with other initiatives like Matrix and so on was on the slides. Can you talk about that?
Yeah, IPFS, for people who don't know, is Interplanetary File System, the idea of one file system that is accessible all over the world. I think IPFS is a great example for this kind of thing. And we would love to integrate it. It's just, it's only so many hours of the day, in the day question, really. We've been focusing, so right now, I mean, it's something I'd very happily, if someone knows IPFS and wants to try and integrate it into something, I would happily work with them. My personal focus is on the lower hanging fruit, I think, or at least from my perspective, based on what I know, and that's like some of the mirroring stuff, some of the like the library box, local internet-free box, the Bluetooth. So that's based on the pool of skills and interests of the people who've done the work. That's part of what I hopefully am trying to, what I'm conveying here, which is that this needs to be decentralized in effort. There's so many ways, and it's like, okay, how can we find ways to tie all these things together and make it so that, messages can go from a Bluetooth mesh over the IPFS to then the centralized internet and back and work without people thinking about it.
Okay, unfortunately, our time is now up. So find Hans-Christoph here at the Congress if you have more questions later at any place around here, I guess.
Yes.
So, and yeah, let's give a warm hand of applause for Hans-Christoph.
Thank you.